Good afternoon, everybody, and welcome to our webinar expert series. Today we'll be talking about Dexi pipes, which is a feature on our professional and upper level bundles. So today we have Taha, who's one of our resident experts, who's going to present the tool to you and basically talk about what pipes is used for, and also, obviously, most importantly, to help you guys and give you a few pointers in terms of how you can use that tool successfully. There will be some questions at the end, so you can drop a question into the panelist box at any point that you wish to do that. And then, as I say, we'll have a Q&A session at the end. If there are further questions, we can also provide an email address at the end so that you can send those questions and we'll answer them directly back to you. So without further ado, because time is reasonably limited, I'm going to hand over to Taha, and then I'll pick back up at the end of the demonstration. Taha, over to you.
Thanks. Hello, everyone, and welcome to this Introduction to Pipes webinar. So we're going to discuss 5 points in this session. We'll start by talking about how to control other robots, then how to align the output of several robots and remove potential duplicates. We'll also talk about processing data with JavaScript and storing data in datasets. Then we'll demonstrate how to use the Google Maps Geocoding API add-on and the Foursquare add-on. So we'll start with the first point, which is the primary functionality of pipe robots. I have 3 extractors for the Gucci.com website. The first one is supposed to return the categories URLs. So all these steps are just to traverse the main navigation menu on the website and return the categories information. The second extractor is supposed to take this data as inputs and fetch the links of the products under each category. And the last extractor is supposed to take the products links as inputs and return the product information. So as you can see, there are several steps in each extractor, and if it was a single robot, then we'll probably have about 100 steps in a single extractor robot. So without pipes, I have to either manually pass the results of each extractor to the following one as inputs, or use the API. And the third option is to build the pipe robot to do that. So I'm going to press the new button and choose create new robot. Select the pipes option. And this will open the pipes editor. In this right sidebar menu, we have the full list of available actions in groups. The primary group is the dexi.io group. And of course, the first action and the most important one is execute robot. And this is the action that I'm going to choose in this case. So I'm going to drag and drop this option. And this will open the node configuration dialog, where I can choose the first robot in the process, which is the categories robot. Then I press update. And the result of this first extractor will be exposed as an object. So I'm going to open this again. the result of the first robot is exposed as an object, and to access its fields, I need to use the asFields nodes from the transforms group. So I'm going to connect the output of the execute robot node to the asFields node to expose the fields of this object. So this is one option. The second option is to just click on the output field, then drag and drop, and choose transforms as fields. This will expose the output of the first extractor as for text fields. And now I can pass them to the second robot in the process. Same thing, add an execute robot node. So sharing my screen slows things down a bit, but the list will eventually show up. So the second robot is the products links, and this since this this particular extractor takes inputs, then the max concurrency settings applies, and I can change the value if I want. I can set it to 3 or 4 or 5. Then update, same thing. Now I need to link these input fields to the second execute robot node. And to do that, same thing with drag and drop actions. Or if the fields share the same names, I can just select the two nodes, then choose the connect option from this menu that shows up. And the fields that have the same names will be automatically connected. So same thing, the result of the second extractor is an object, and I'm going to expose its fields using a drag and drop action, then transforms, and I choose the asFields option. And now we can include the last extractor, which is the robot that will fetch the product data. And same thing, this robot takes inputs, so the max concurrency settings applies, and I can change the value if I want. And here the fields share the same name, so I'm just going to select the two nodes and choose the connect option. And last step in this process is to eventually expose the product data as a list of text fields. And this is pretty much all you need to do to link these three extractors. After saving, I just close the editor. And now I can test this pipe by creating a new run and pressing execute now. So the pipe is going to run the categories URLs robot first. And as soon as some links are available, it will start the products links robot. And as soon as some products links are available, it will start the main extractor to collect data. So we've set concurrency level in the second execute robot node to 5. You can see 5 concurrent executions for the products links extractor. And the main extractor started to run, so we'll shortly be able to see some data in the results tab. And basically the process will run until all the categories and products links have been explored. So basically this covers the primary functionality of pipe robots, which is controlling other robots. So I can just stop this execution and move to the second point in this webinar. Which is aligning the output structure of several extractors. So this is kind of so basically I created 3 robots for the same page, but each one has a different output structure in terms of number of fields and also names. And we're going to build a pipe robot to align this the output of these three extractors. So the names of the output fields are different or just not in the same order. And I'm going to start by creating a data type to model the output structure that I want in this case, which is going to match the output structure of the first extractor. So I'm going to open it in a new tab to use it as a reference. And then I can create a new data type. We have in this case 8 output fields, all text. After adding all the fields, I can save the data type. And now I can edit this pipe which is supposed to run these 3 extractors. So I'm going to open this pipe and finish building it. So basically there is an execute robot node for each extractor, and we expose the output of each robot separately. So there is a different number of fields for each one. And in this case, we have 2 options. We can use the data type node from the dexi.io group. So I just drag and drop this option. And I have to link it to the data type that I just created. And now I can match the output of each extractor against this this data type. So using drag and drop actions. So these fields have the same name, so I'm going to use the connect option. The second extractor things are a bit different, so I'm going to do this manually. Education, lawyer experience to experience, lawyer name to name, telephone to phone. So you saw me link the fields to the same data type node. You can also add several nodes. You're not limited to just one. So I'm going to add another data type node. Link it to the data type, and same thing. Connect the output fields together. So after saving the pipe, I can just run a test execution. And we'll have a common output structure for all the robots that the pipe controls. And the results of the three extractors will match the output structure of the first one in this case. So this is one option to align the output structure of several robots. The second option, in case you need to do something else besides only aligning the output structure, is to use the fields to object node instead of data type. So I'm going to delete these data type nodes and instead use fields to object from the transforms group. So same thing, I need to link it to the data type. And then I can connect nodes together. I can either link everything to this single fields to object or add additional fields to object nodes. So we'll stick to one node in this case. So here I used the fields to object because I want to do something else besides aligning the output structure. And I'm going to demonstrate how to remove duplicates. Since this is an edge case in which I used built 3 extractors against the same page, we can test the remove duplicates functionality. And here I need to choose the filter duplicates rows from the collections group. So I drag and drop this action, and they connect it to the output of fields to object. I need to specify which fields to use as keys. You can choose more than a single field, of course. So we'll choose name in this case. Then I press update. And since the output of filter duplicates rows is an object, I need to expose its fields. Same thing, transforms as fields. And this makes the pipe remove duplicates after extracting the data. So we'll check the execution that we started a few minutes ago. And it returned 132 records. If we start a new execution, we should get a lower number since the pipe is going to remove duplicates now. This should take only a few more seconds. As you can see, this time we got only 47 records. So in the 132 records, there was of course many duplicates since the data was being extracted from the same page. Basically, this is how you align the output structure of several robots. And if you want to, you can filter duplicates too, like demonstrated. So we'll move on to the third section of this webinar, which is about processing data with JavaScript and storing it in datasets. So basically what I'm going to do is simulate fetching data from a third-party API by calling this all data endpoint, which returns this JSON data, which is basically a list of information, list of people with some information about each one, like the name, emails, and his address. So I'm going to build a pipe to fetch this JSON. Same thing, create a new pipe robot. And for the URL, I'm going to use a fixed text node. I enter the URL in the text value field, and they can change the name. Then I press update. And since we have an HTTP request to make, I'm going to add the HTTP request node, which takes 3 input fields. In this case, I have only to connect the URL field. But if it was a post request, you can include the body and also any additional headers. I don't have to change any settings in this case, since the default is GET request. And I'm going to process the body of the response, which is the JSON data, using JavaScript. So I'm going to add the custom logic node from the transforms group, which allows you to run JavaScript code. And in this case, I need to specify an input field by typing the name of the input field and pressing enter. And I can refer to this input field in my code as JSON. So the code I'm going to use is this JavaScript snippet, which basically parses the JSON. Then for each person in this list, it's going to try to get the first name, the country, and the email. So I'm going to copy this code and paste it in the configuration window. And you can see that we are returning an array of objects. So I'm going to check the output is list, since this is an array, and change the output type to object. Since the code is constructing a new object for each person and pushing it in this array. Then I press update. And they can connect the body output field of HTTP request to the input of the custom logic node. So the output of custom logic is list of objects. So I can use the each row option and expose the fields of each object with the asFields node. So we can quickly test this. So this pipe doesn't control any robots, so it's not going to start sub-executions. We'll just get the results in the results tab shortly. And we have this cleaner output. So we started from this row JSON, and we've got this list of only the data that we need in this case. So I'm going to now store this data in a dataset. But first I need to create a data type to model the output structure of the pipe. So I'm going to create a new data type. and add the 3 fields for the first name, country, and email. Then save. The next step is to create a data set that's connected to this data type. So I'm going to create a new data set. And in the data type field, I'm going to choose this new data type. Then press save so that the system can reindex the data set. And now I can update the pipe and make it store data in this data set. So I open the pipe. And now instead of using as fields, I'm going to use the fields to the object to fields node from the transforms group. I link it to the person data type, then to the output of each row. And this gives us the output of the pipe, which is 3 text fields in this case. So I can now use the fields to object node, same data type connection, link these 2 nodes. And finally, I can save the data in the dataset using the save row to dataset option. I have to connect it to the dataset that I've just created. I can leverage concurrency in this case. And now I can save the pipe and run a new execution. Actually, in this case, I think that these 2 nodes aren't necessary. We can just remove this one. And link each row to the save row to dataset node. So basically, this allows me to both store the data in the dataset and view its results in the execution. So I'm going to run a new execution. And besides including the data and the results, it will also be inserted in the dataset. So we have data in the execution. And now if I open the dataset, we should find the same data here too, 8 records and 8 records. So data types are basically behave like datasets behave like database relational database tables. So if I configure a key in the data type, then the dataset will respect this key configuration. In case I want the dataset to be duplicates free, for example. So basically, this is how this is a simple example of how to process data with JSON. We use the custom logic node and then store the data in a dataset. One advantage of dataset is to bypass the 2 weeks lifetime of executions. So in a couple of weeks, this execution will be permanently deleted and they won't be able to download data from its results. But the dataset will be always there, and I can access the data here whenever I want. It won't be deleted. Only executions will be deleted. We can now discuss add-ons. So we'll go to start with the Google Maps Geocoding API. I have this add-on already configured. Basically, you just need to enter your API key, and then you can start using this Google service in a pipe robot. So I have a list of addresses in this dataset from a few American states. It's raw text, and I'm going to use the Google Geocoding API to have a more structured data in this case. So I'm going to build a pipe that will query the Google Maps Geocoding API. So I create a new pipe. And since we have the data in a dataset, I need to access the rows of this dataset. And for that, I'm going to use the for each row in dataset action from the dexi.io group. I have to specify which dataset to use. In this case, it's called addresses. Concurrency can be leveraged in this case too. Then I can press update. And the rows of the dataset are exposed as objects, and they can access the fields of this object, which is just one text field. Then I can add the address lookup action from the geography group. I have to select the add-on. I can enter a region name if necessary to kind of assist Google in fetching information about the address in question. And you can also change the language. So I'm going to stick to the default settings. Then I can connect the address input field. And finally, I just expose the address data. As you can see, it's all text fields. So just 4 nodes in this case. And we can test this pipe. The quality of the results depends on the country. So if it's a US address or somewhere in Europe, usually you get very accurate results. In other parts of the world, the results might not be that accurate. But usually US and Europe, it's pretty accurate. And the execution is done running. And we started from a raw address string, but got this more structured output, including latitude and longitude information. This is if you have address information, but if you have latitude and longitude coordinates, then you can do the reverse action, which is looking up latitude and longitude coordinates. So I have a list of coordinates in this dataset. And now I'm going to do the opposite of what I did in the first pipe. So I'm going to create a new pipe robot. And you can see that the second option of in the geography group is latitude and longitude lookup. But first I need to access the dataset. Same thing for each row in dataset. I link it to the Latiranges dataset, change the concurrency if I want, then press update. Then I expose the output of this node, which is two text fields. And I drag and drop the latitude, longitude lookup node, select the Google Maps add-on, and then I just need to link the two input fields. Same thing, so the output is an object, and I'm going to access its fields, which is the same output structure as address lookup. So these two nodes have the same output structure. The difference is that latitude and longitude lookups don't return one result. It will return many results depending on how accurate the coordinates are. So instead of directly exposing the results of the Latirange lookup, I can first filter the data to clean it up a bit. So I choose collections, filter rows, and I'm going to exclude the results that don't have street value. So street is not empty. Then I press update, and this gives me two lists: the records that don't match this criteria and those that do match the criteria. I'm going to stick to those that match the filter and expose the results within a fields node. Now I just need to run an execution. So we have 49 records in the inputs dataset, but the results should be, the number of results should be a bit higher, since the Google Maps Geocoding API can return more than one result for each query. So I got 85 results. And same thing, the accuracy usually depends on the country. So this is how to use the Google Maps Geocoding API add-on. In the last section, we mentioned in the newsletter that we're going to discuss Facebook, but after its recent leak scandal, some data is no longer accessible, like events data or groups data. So basically, it used to be possible to look up users, events, groups, pages, and places, and also users. But some of this functionality have been paused by Facebook until they review their API policy. So places in an area is still working. So basically, you choose the Facebook add-on and specify the area in which you want to run a search. And hopefully this is still working. So I'm going to start an execution. So we'll see what the new Facebook policy is going to be and adjust accordingly. So it looks like it's still working. But instead of discussing Facebook, we'll discuss Foursquare, for which we also have an add-on. And I'm going to show you the 3 actions that we support for this service. Basically, you can look up users by their IDs, fetch data about likes for a particular venue, or run a search in a particular place. So for users, you just need to use the user by ID node. And this node, you just need to select the Foursquare add-on. So basically you configure the Foursquare add-on here. By entering your client ID and client secret. Oh, sorry. And then you just select the add-on in the node configuration dialog. As I mentioned, this lookup takes user IDs. So I have a few IDs already in this run. And I'm going to run this pipe against them. And depending on how much information the user in question provided when signing up, you'll get the data in this format. If it's a text feed, then it's just a text fields too in the results. And if it's an object, you get the data in JSON format. You can process it further in the pipe itself or with a few lines of code, of course. So the second action that we support for Foursquare is venue likes. So same thing, you need to provide IDs in this case, and you get information about the number of likes and information about who liked the venue in question. So I'm going, same thing, you just need to select the add-on when adding this node. And they have a few IDs against which we can test this pipe. This should take only a few seconds, and this is how the output looks like. Count of likes, the summary, and the who liked the video in question. You don't get all the likes. I think it's about user settings in this case. And the last action that's supported for Foursquare, and probably the most useful one, is venue search. So same thing, you just add the venue search node, select the add-on, and choose the area in which you want to run a search. In this case, I selected San Diego, California. And the output is an object, so I just expose its fields, which is a list of text fields and some objects or object lists. And depending on the output structure that you want, you can process the data further to get only the information that you're looking for. This would require using data types as we saw in the second section of this webinar. So I'm going to quickly test this pipe. We don't have to supply inputs in this case. So I'll just start an execution. And Foursquare is pretty generous in terms of data, since you'll probably pay for the API. I think the free version is quite limited. So this execution will probably return a big number of results. So I'm just going to, we are at about 50 results now, so I'm going to stop it. And quickly show you how the output looks like. So basically either plain text information or JSON for the objects. So these are the three actions that we support currently for Foursquare. And this covers the first section of this webinar. And we can now answer any questions that you might have about what you've seen so far.
Thanks, Taha. I've been collecting some questions on the Q&A in the background, so thanks for the people that have sent in a couple of questions. And it might be easy if I just read those out to you, Taha, and we'll go through each of them. Couple of quick ones. So I have one here. What is the recommended level of concurrency in the execute robot node?
Yeah, so depending on the number of execute robot nodes, I think that you'd better stick to five concurrent executions as the maximum number. If you go past 5, 6, or 7, you'll either stress the target website and take it down, so the execution will just fail. Or if the website has an anti-bot system, then it will be easier for them to block the robot. So if you stick to a small number of concurrent executions and get the data in, for example, 1 day, is better than using a big number of concurrent executions and having the robot blocked. Unless you can, of course, throw more private proxies in the process. In that case, you might be able to increase the concurrency level beyond 5. But I think that you should stick to 5 or 6, 7 concurrent execution per execute robot node.
Okay, thanks, Taha, for that. Can I store data directly in a database with pipe robots?
Yeah, we can do that. So there is a built-in step for doing this. In the data stores group. So basically it's one single action, write row to SQL DB. And we support so far 4 engines, all relational. So MySQL and Oracle, Postgre. Recently we added support for SAP HANA, and of course SQL Server. The only condition when using this option is that access to the database should be granted to all IPs, since the system will use a different IP every time it inserts a new record. The only condition is that access to the database should be granted to all IPs. If you're okay with this condition, then you can use pipes to directly store data in a database.
Wonderful. Thank you for that. Can I debug a pipe when its execution fails?
So extractor robots have debug mode, and pipes too. So basically, if something goes wrong in an execution, then if you go to the results tab, you'll see this green bug icon in which you can click to enter debug mode. And here, if something went wrong, it will be highlighted in red. So in this case, something went wrong with this extractor. And you'll be able to use this mode to figure out what went wrong. So same thing, you can step forward and backward in the timeline. So this is a debug mode for pipes. And if the pipe in question is controlling other robots, then you can start by looking at the executions list. If something went wrong, then it probably happened with one of the extractors that the pipe controls. And if you check the failed ones, then you might be able to figure out what's the problem exactly. So in this case, we're probably getting connection refused. So this is a real-world project. So we've been collecting data from Gochi.com for a while, and it probably started to block some of the default IPs, which gives us the connection refused error in the log.
Okay, thanks, Taha, for that. I've got another one from one of the attendees. Can I stop an extraction and restart it later at the same point where it was paused?
With pipes, that's not possible. If you stop the execution, then so pipes basically don't support the resume functionality. You can only resume extractors if the extractor in question takes inputs.
Thanks, Taha. What is the difference between running 3 extractor robots compared to using pipes?
The difference is that you'll have to either do some manual work or write code to pass the results of each extractor to the second one. With pipes, you have one robot to run, and you directly download data from its executions. With 3 extractors or more, you have to run each one separately, either manually or using the API. So it's a productivity question.
Excellent, thank you, Taha. And would a JavaScript snippet that works in a browser console work in the custom logic node as well?
When it comes to JavaScript, what works in the browser console works in extractor robots. For pipes, what works in Node.js works in custom logic. So if I wrote some JavaScript that runs on Node.js, then it should work in the custom logic node too.
Thanks, Taha. I had another question come in, which was asking about the difference between an object and field.
So the difference between the object to fields node and I didn't understand the question very well.
Sorry, Taha, that's what's there. So again, it just said, I'll read it again, sorry, so many here. What is the difference between an object and a field?
Okay, so I'm going to do a best guess in this case. So here I have an execute robot node. By default, its output is an object. You can see in this upper right corner of the window, if I hover over result, you see that the connector type is an object. With objects, I can only add actions that can also manipulate objects, like saving row to a dataset, filtering data, or doing some transforms. If I need to access the fields of this object, then I need to use the asFields node. So here we have an object. Here we have 4 text fields, which I can use for actions that are supported for text fields. So it's a question of which form of data you want to work with. If you want to work with objects, then you don't need as fields. If you want to work with the fields of the object in question, then you need as fields. This is my best guess at understanding the question, but we can discuss this later through the support channel if I got it wrong.
Taha, that's wonderful. We're really up against on the time now, so I'm probably going to bring it to a close. Taha, could you just put up the last slide with the email addresses on it, just so everybody can see that?
Sure.
Thanks everybody for the questions today. I hope you found that to be very useful. Please do give us an email or drop us an email into the support at Dexi address. You can see there below the question mark. You can also get me, Chris. I'm responsible for sales at Dexi, so feel free to ask a question. As I said at the beginning of the webinar, the pipes feature is available for our professional bundles and hire. So if you're currently not on that, but you're very interested in what you've seen today, do give me a call and I'll be very happy to help you out. So I think on that note, I'd just like to wrap up the webinar and thank Taha for a great presentation today. As I say, feel free to follow up with any questions. Our next webinar is on May the 5th, and that's for people who haven't had a chance to build their first robot yet. So you'll see an invitation for that coming round shortly. Okay, once again, thanks everybody, and I'm going to leave it there. Thank you very much.